What's up everyone? Welcome to another RTcmix tutorial. In this video we'll take a look at a few ways in which we can get more interesting and expressive outcomes with our scripts. So we can start with a very simple one and type something like a for loop using the st variable as the counter variable. So st equals to 0, and as long as st is less than 5, the loop will continue, and each time it repeats, st will add 0.2 to itself, and we can include a wavetable inside the loop and use the st variable as start time, then say that the duration is 1, the amplitude is 8,000, then use 440 as a frequency and 0.5 as the panning value. And while we're at it, let's add an envelope with makeTable, which we already know how to do. So let's say env equals makeTable line 1000 0011. I'm gonna say 5 0.8 and then 500 0, and we'll multiply the amplitude by the envelope variable, and let's hear it. Yeah, super boring, right? Now before we continue, let's replace the arguments of wavetable with variables, which will help us keep track of what we're doing. So let's say the doer variable equals to 1, and we replace this one with the doer variable. Then let's say amp equals to 1000, and we replace this value with the variable, and then fq equals to 440, and we replace this one with fq, and panning equals 0.5, then pan. Okay, now we can start. So until now we've been using a wavetable, which by default performs sound synthesis taking as a reference a sinusoidal waveform. However, we can actually use more options than just a sine wave if we take advantage of an optional argument in wavetable, which is the waveform argument. And to specify the waveform, we need to use makeTable function, but not with the line table type that we've used to specify envelopes, but with the wave table type. So if we typed something like, let's say that the variable we're going to use is wf for waveform, and we type wavetable wave 1000 and say sine, and the waveform argument goes at the end of wavetable after panning. So let's say wf for here, and these arguments are, of course, the first one is the table type, the second one is the table size, and the third one is the waveform type specified as a string. So right now we're not really changing anything because we're still asking for a sine waveform, but we can choose other waveforms such as these. So I'm gonna copy these as a multi-line comment, so we can ask for a triangle wave with the string tree. Then we can ask also for a square wave with the string square. We can ask for a sawtooth wave with the string saw, and for last we can also ask for a pulse wave with the word buzz. Not only that, we can even go further and add a number next to the waveform type, and that number would specify how many of the first harmonics in that waveform we can use. So if we were to say triangle wave and 7 and save this file, we can play this and we get a different waveform. Now, still pretty boring, but don't lose faith, because the next thing we can talk about is implementing random functions in our scripts. And in this tutorial, we will use 4 different random functions. So those functions are random, the random function, then we have the trand function, we also have the irand function, and the pigrand function. So let's take a look at these one by one. So the random function doesn't take any arguments, and what it does is it outputs a random floating point number between 0 and 1. So this one is actually useful for example, randomizing the panning of each note. And so what we can do is, instead of say 0.5 for every note, we can say random, and we can play this, and we get random panning. Now the next one is trand, which takes 2 numbers as arguments and outputs a random integer between those 2 values. So this one would actually be beneficial for randomizing the amplitude of each note. So instead of saying amplitude equals 1000, we can say amplitude equals trand, and let's say 1000, 3000, and let's play it. Yeah. The next one is irand, which is the same as trand, except it outputs floating point numbers as opposed to just integers. So this one would be useful for randomizing the duration of each note. So we can say irand, let's say 1.5 and 3. We can play this. Yeah, and for last, we have pigrand, which takes 1 or more numbers as arguments and randomly chooses one of them. So this would be useful for randomizing frequency. So we can say pigrand, and for instance, say that it picks randomly between these frequencies. So let's play this one. Yeah. Now let's see what happens if we run the script again. Yeah, so if you noticed, every time we run the script, we hear exactly the same sequence of notes. And this is because by default, RTcmix chooses the same random structure, which is referred to as a seed. And to make sure the seed is different every time we run the script, we have to use the srand function at the top. And so this will guarantee that every time we run the script, we'll get a different outcome according to the parameters we gave. So if I run the script again, we should hear something, a different sequence of notes. Yeah, so if we do it again. Yeah, so different every time. Now we've solved that problem. And the last thing I want to show you is how to specify pitch in a more intuitive way than just specifying frequencies. And the way we do that is with the CPS midi function. And so if I said CPS midi and I said 60, what this would do is take the midi note value of 60, which is a middle C, and convert it to hertz. So what we could do is create a variable called pitch and say pigrand and say 60, 64, 67. Actually, let's do sort of like a pentatonic scale, so 62 and 69. And instead of doing this with frequency, what we'll do is say CPS midi, and we include the pitch variable here. And so we can play this. Yeah, so we don't have to stop there. We can go even further and randomize the register of the pitches. So we can also create another variable called, let's say, octave, oct for octave, and say pick rand, so pick between -12, 0, and 12, and we will add this variable to pitch, and we'll get different octaves. And we can also randomize, for instance, the number of harmonics for each note. So we can say instead of 3, well, actually, let's change it to saw. And let's say the saw plus T-rand, so 2 and 16. And we'll get a different, slightly different timbre for each note. And we can even use a very simple but nice effect called beat frequencies, in which you can simultaneously play 2 or more waves with slightly different frequencies to generate a pulse. And so if I do something like this, I make 2 copies of wavetable, and to the frequency I will add a random number between -3 and 3, and I do the same for the other one. We will not get a pulse effect, but it will resemble more a type of chorus effect, so we can play it. Yeah, so now that we've covered random functions using other waveforms with wavetable, and another easy way to specify pitch, it might be a good place to stop. I hope you'll find using all these tools beneficial to your own musical ideas, and as always, I encourage you to tweak around with this script or write new ones from scratch. Feel free to leave questions or comments if you have any, and see you in the next tutorial. Thanks for watching.